Welcome to 5.3. We're going to talk about more key features of graphs. We're going to talk about x and y intercepts and intervals where graphs of functions are positive and where they are negative. So let's dive right in. We've already talked about x and y intercepts a bit, but let's just write a few things down here. So for x intercepts, they are also called zeros of the function. X-intercepts are also called zeros of the function. And they are points on the graph where y is 0. So points on the graph where y equals 0. So we'll look at an example in a little bit. But places where the graph crosses the x-axis. And y-intercepts, they are points on the graph. Or if it's a function, there's only going to be one y-intercept, because x equals 0 can only have one y value paired with it. So we're going to say point rather than points for this one. So a point on the graph where x equals 0. So a point where the point where the graph of the function crosses the y-axis. Okay, and if it's a function, it can't have more than one y-intercept. So now let's talk about positive and negative. So remember, positive means greater than 0, and negative means less than 0. Okay, and what we're going to do on these graphs is we're going to find intervals, x values, of the graph where the y values are positive. X values of the graph where the y values are positive. Or greater than 0. Graphing wise, what that means is the graph is above the x-axis. So we'll just say it that way as well. Graph is above the x-axis. Okay. Let me just look at this graph down here. So here's my x-axis. The horizontal is the x. The vertical is the y. And remember, when we're up here, the y values are positive. So if we're looking for places where the y values are positive, that's going to be above the x-axis. When we're down below the x-axis, the y values are negative. Right? Down below the x-axis is where the y values are negative. So when we ask where a function is positive, we're really asking where is the graph above the x-axis. And then we'll do the same thing with negative. So negative, when we ask for intervals where the function is negative or where the graph of a function is negative, it's going to be all the x values of the graph or of the function where the y values are negative, meaning less than 0. Negative. So in the picture, what that's going to look like is it's going to be x values where the graph is below the x-axis. So you're looking for places or x values where the graph is below the x-axis. Because as we said, over here in this example right here, y values will be negative when your points are below the x-axis. So what we have here, well, let's just do the example. Let's do the example. So example 1. First thing we're going to do is we're going to find the x-intercepts. So let's find our x-intercepts. So x-intercepts, that's places where we cross the x-axis. I think I'll do those in green. So we have an x-intercept right there at -1, 0. We're just going to count by 1. They didn't show us the scale, so we'll just assume that it's counting by 1. And then we have 1, 2, 3. So we have another x-intercept over at 3, 0. And then we have a y-intercept. Now those x-intercepts are going to help us find intervals where the graph is positive or negative. The y-intercept isn't going to help us so much. The y-intercept is right here at 0, -2. Okay, now we're going to identify intervals where the function is positive and intervals where the function is negative. We have to do both. Notice we're doing both. So let's do both of those. So what I will do, I think I will go and highlight, let me just highlight in yellow, where the function is positive. So it's above the x-axis here, okay? So we're going to write that interval. And then it's above the x-axis over here. So we will write that one as well. So let me go back to my pen. And we'll write down the intervals where it's positive. So -∞ to -1. And we're not going to include -1 because at -1, the y value is 0. And 0 is not positive or negative. And then we're going to do our union symbol. And we're going to skip over to the right side over here, where we go from x equals 3 to infinity. So it's positive over there. And then for the negative, let me switch back to my highlighter. Where is the graph below the x-axis? Well, here on this part. And that's going to be from -1 to 3. So from x equals -1 to x equals 3, for those x values from x equals -1 all the way over here to x equals 3. But again, we're not including those n values. The -1 and the -3 are not included because they're where the y values equal 0. All right, let's do example 2. It's going to be very similar, except we're going to have to do some estimating. So we're going to do a little bit of estimating on this one. The first thing we're going to do, though, is we're going to find the x-intercepts and the y-intercepts. So that's not quite -1, so let's call it -0.8 or 9. Either one is fine. The y value there is 0. And then we have another x-intercept over here. We're going to call that 2.8, 0. We'll just do our best estimate there. And then our y-intercept right here at 0, -2. 0, -2. That's our y-intercept. And now where is it positive? Well, let me highlight where it's positive. Where is it above the x-axis? Remember, it's positive when it's above the x-axis. Let me get my highlighter. I'll highlight this in a lovely purple. Where's the graph above the x-axis? Okay, over here, it's above the x-axis. And then again over here. So let's write that down. I'll go back to my pen. And it's going to be the intervals, which x values, for which x values. So from -∞ up to -1, it is above the x-axis. And then again from 3 to infinity, it's above the x-axis. Notice it's going up forever, but it's also spreading to the right. So from 3 to infinity. And then negative, Well, it's going to be in the middle between the -1 and the +3. Right? We need to highlight that. We can. We'll highlight it up. Where is it? Below the x-axis? Right in here. From x equals -1 over to x equals 3, which is this right here. Okay, let's go on to example 3. Get my pen back here. All right, x-intercepts. Oh, I've got a lot of them. I've got 3 of them. I've got 1, 2, 3, 4. So we've got -4. We've got -1. And we've got 2. All right, so we will put those down. So we've got -4, comma 0, -1, 0, and 2, 0. Those are our x-intercepts. Then for our y-intercept, we have 0, -2 again. We're going to assume that we're counting by 1. Seems like we can only get -2s out of this. Okay, where is it positive? Let me highlight the positive parts. Where is it above the x-axis? I think I'll highlight in yellow this time. It's above the x-axis between -4 and -1. And then again, let me write that part down. From -4 to -1. And then again from, it's above the x-axis here, from 2 to infinity. All right. From 2 to infinity. From here, forever to the right. And then negative. Now be careful, don't miss anybody. We've got negative y values. Where is it below the x-axis? It's going to be below the x-axis over here from -infinity to -4. So we'll write that part down. And then again from -1 to +2 in there. Okay. So from -1 to +2. All right, and that should include, well, yeah, okay. There we go. All the x values except where we have all the x values in the domain except where the y value is 0. All right, let's do example 4. It looks really complicated, but it's not really any more complicated than the others. So we're going to estimate our x-intercepts. We're going to start here. We're going to call that, let's see, 1, 2, 3. That's -3, 4, 5. -5.6. Let's call it that. So -5.6, comma 0. And then we've got another one at -3. We'll call that one 6 as well. -3.6, comma 0. And then we have a final one over here. We'll say that's 2.4, comma 0. And I can't tell what my y-intercept is. I'm just going to mark off a scale here and call that 1, 2, maybe I'll call it 2.2. 0, comma 2.2. We'll do the best we can with this one. We'll just kind of estimate. All right, where is it positive? Let's see. I'm just going to do it all at once here. I think it's going to be positive from -infinity to -5.6. And then again from, well, let's write that one down. Whoops, that's not a good color. infinity to negative 5.6. Then we'll pick up again here at negative 3.6 and go over to, all the way over to 2.4. Oops. And then that's it. From there, it stays below the x-axis. So we've identified all the places where it's above the x-axis. Now we have to identify where it's below. Where is it below the x-axis? So below, we'll do, let's do this in green. Here, from negative 5.6 to negative 3.6. If it helps, you can label that one as negative 3.6 since we keep coming back to that. And then it's going to happen again over here at from 2.4 to infinity because it never comes back above. So x equals 2.4 to x equals infinity. Notice we are using x values. When we're trying to figure out where intervals where it's positive and negative, we only use x values. These are x values. Identify all x values where the y values are positive, and then identify all x values where the y values are negative. Okay, we're going to flip to the next page. We're going to do example 5 and example 6. They look really complicated, but they're not so bad, really. So here we go. Example 5. So we have a graph, and we're supposed to find x-intercepts. It's a little fuzzy, but let's see. X-intercepts. There's only one. There's this one right here. We're going to call that, oh, look at my scale. That's 2, 4, 6, 8. This must be 3 right here. Okay, look at the scale. This next mark is a 4. So that's got to be x equals 3. So that's 3, 0. That's our only x-intercept. And then our y-intercept, again, we're counting by 2s. 2, 4, 6, 8, 10 is up there. That looks like 0, 9. And then positive, where is it positive? Let's see, from x equals negative 6. Notice we're above the x-axis over here. So from negative 6, we're going to use a bracket this time because at this point right here, the y value is positive. So negative 6 is included. And then we're going to go over to negative 2. But we're not going to stop because from negative 2, we're going to go on to 3. Where we do need to use a parenthesis because at x equals 3, the y value is 0. And let's see. Oh, I did have another x-intercept that I missed. Look, it's right there. That's 4, not quite 5. We'll call it 4.5. Okay. So we pick up positive again at 4.5, but we end at, getting a little carried away with those, we're going to end at 8, not including the 8 because that's an open circle. See that open circle right there? You can't include the 8. Okay, and then negative. Where is it negative? Just between the negative 3, or the 3, sorry, the positive 3, between the x equals 3 that we have here and the x equals 4.5. Which is right here. That point right there, where it's 4.5. Okay. All right. So from 3 to 4.5. And this little break that we have here at x equals 4, not a big deal because at x equals 4, we're in the negatives. Jump up there, we're still in the negatives until we get to 4.5. So a little more complicated, but not bad. Okay, example 6. This will be the last one. So x-intercepts. I'm going to make sure I don't miss any this time. Oh, I only have one. It's right there. 0, 0. The y-intercept is the Same, 0, 0. That origin is the x-intercept and the y-intercept. Where is it positive? Well, let's think about it. It's going to be positive. Oh, the graph is always above the x-axis except at that point where it's actually touching the x-axis. So let me highlight this in yellow. I'm not going to include x equals 0 because at x equals 0 we are actually touching the x-axis, not above it. Okay, I will include x equals 1 because it's closed here and open there. I will include all the x values over to 2 and then everything from 2 to infinity. So it's positive everywhere except at x equals 0. How are we going to write that? Well, we're going to go negative infinity to 0. We cannot include 0. So then we'll do a union. We'll pick up again 0, infinity, but we've left out the 0 because those are parentheses. And then negative, it's never negative. So we say none or D and E, whichever one of those we need to use in the homework assignment. And that is 5.3.